Question 18. The diagram shows three towns, X, Y, and Z. Town Z is due east of town X. The bearing of town Y from town X is north 39 degrees east, and the bearing of town Z from town Y is south 51 degrees east. The distance between town X and town Y is 1,330 kilometers. A plane flies between the three towns. So part A, mark the given information on the diagram and explain why angle XYZ is 90 degrees. So the first thing is town X and town Y, the distance is 1,330. So I'm just going to write that in first. Now, we have two bearings to mark in. The bearing of town Y from town X. So from town X means I'm going to draw a north-south line, a north-south axis. Okay, I'm going to call this north 1. And it's north 39 degrees east. So from north, we're going to mark in the angle 39 degrees in an easterly direction. And the bearing of town Z from town Y. So there's town Z. So from town Y, okay, I'm just going to draw in another north-south axis. I'm going to call this north 2. Okay. And I'm going to call this south 2. This one is south 1. If we'll need it, we'll use it if necessary. So this just marks in these two axes. They're parallel to each other. And we need to also mark in 51 degrees. Okay, so that's that compass bearing there. So that one's 51 degrees. So mark the given information, which we've just done, on the diagram and explain why angle XYZ is 90 degrees. So this is XYZ. Now we can see here that the axis, this N1, S1, this line, is parallel to N2, S2. That means that this angle here, N1, XY, is alternate to this angle, X, Y, S2. So this one's going to be 39 degrees. So we'll write that in. So angle N1 XY is equal to angle XYS2, which equals 39 degrees. And we need to say alternate angles on parallel lines. Okay. N1, S1 parallel with N2, S2. You could write anything to that effect. I've just used some terminology there and some symbolism, but anything that states alternate angles and states that N1, S1 and N2, S2 are parallel to each other and that XY is a transversal even would work. So anything along those lines is fine. Now, angle XYZ is equal to angle XYS2 plus angle S2YZ, okay, which equals 39 degrees plus 51 degrees, which equals to 90 degrees as required. Okay, so this is the 90 degree angle. Part B. If the speed of the plane is 570 kilometers per hour, how long does the flight take from town X to town Y in hours and minutes? So we can use our speed, distance, time triangle. Okay, so distance is equal to speed multiplied by time. And we want the time. So time is equal to distance divided by speed. So time is equal to the distance, which is 1,330 kilometers, divided by the speed of the plane, which is 570 kilometers per hour. Okay. Divided by 570, and we get 7 on 3, or 2 hours and 20 minutes. Part C. Find the distance between town X and town Z to the nearest kilometre. Okay, so there's town X. Okay, town X to town Z to the nearest kilometre. Now, we have a right angle triangle here, and we can use whatever angles we like, really. I mean, it's probably the most convenient to use this angle here as our theta. Okay, so we don't even need the sine rule or the cosine rule at this point. Okay, so there's our theta. We have 1,330 as one of the short sides. We actually want to find the hypotenuse, so we can't use Pythagoras theorem because we don't know what YZ is. Okay, but our theta here, this is going to be 51 degrees. Okay, so I'm just going to put the working out just somewhere here. So our theta, okay, which is equal to angle YXZ, which is equal to 51 degrees. Since 39 degrees plus 51 degrees is, well, they've got to be complementary, they've got to equal 90 degrees from north to east. Okay, and we need, actually I'll go back to the diagram, we need XZ. There's our theta. This is an adjacent side. In fact, if I turn the paper around this way, okay, just let it refocus. Yep. So you can see that's an adjacent side. Okay. We want the hypotenuse, and our theta is 51 degrees. So we're going to use cosine. Okay. So cos of 51 degrees is equal to 1,330 over XZ. So as a bit of a shortcut, okay, if you want to make XZ the subject of the formula, or you take the 1,330 and you place it on top of the cos 51. It's just a much faster way of doing this. So it's going to be 1,330 over cos of 51 degrees. Moving on, and it says to the nearest kilometre, so 1,330 over cos of 51 degrees, and we get 2,113 kilometres, 2113. Okay, and that's correct to the nearest kilometre. So I might just mark this in here, might come in useful later. Okay, and we actually have a part D as well, so I might just put that there, okay, because the diagram's going to be useful. So part D, the plane is going to fly from town Y to town X, stopping at town Z on the way, leaving town Y. The pilot incorrectly sets the bearing of town Z to south 50 degrees east. The pilot flies for 1,650 kilometers before realizing the mistake, then changes course and flies directly to town X without going to town Z. There's quite a bit going on here. From where the pilot changes course, is it a shorter or longer distance to town X than if the plane had flown from town Z to town X? Let's have a look and see how we can work this out on the diagram. Just quickly, plane's here, okay? So originally it was meant to fly to town Z, so that's south 51 degrees east, this way. But the pilot accidentally puts in into the computer south 50 degrees east. So it's actually going to end up somewhere here, the plane, potentially. So I'm going to draw this just faintly in pencil. Okay, so just to make it a little bit easier to see. Okay, so just something like that. So that's what the plane's doing. So starting at Y, it's ending up kind of not quite at Z, but more sort of west of Z potentially, and it flies for 1,650 kilometers. And then from here, okay, the plane is then going to fly to town X. So the question really is asking, is the distance xz greater or less than this distance here, x, and to this sort of where it turns? Okay, so where it changes course, is that a shorter or longer distance? So if we've gone 1 degree back to the west, instead of a 90-degree angle, it's now going to be a, just going to mark it in faintly here, it's going to be an 89-degree angle, because it's originally 90, but the plane's come back 1 degree. So that's 89. Now we have 1,650, that's one side. We have 1,330. We want this side here. This is this distance. I'll just draw it faintly there as well. All right. So we want this distance here. 2 known sides and an included angle. Cosine rule. Okay, so as soon as you hear that, 2 sides and an included angle, you know it's going to be the cosine rule. So by the cosine rule. Okay, let's give this another letter. Let's call this W. Actually, no, we'll call it a different letter. Let's call it, let's just call it A. So we haven't used the letter A yet. W could be misconstrued for west, so let's call it A. Okay, so AX squared is equal to, what are the 2 sides? 1,330 squared, okay, plus 1,650 squared minus 2 times 1,330 multiplied by 1,650 multiplied by cos of 89 degrees. Okay, so AX squared is equal to plus okay, and we get this big number there, so I'll just write that down, 4414801.388. Now AX is equal to the square root of this number, 4414801.388. Okay, so it's good to show what you're working out, and we can just sort of just do square root of the last answer, which is 2101.14. Okay, so we're comparing that against this distance here, 2113. Now, 2101 is less than 2113. Okay, so therefore it is a shorter distance than XZ.